Okay, guys, welcome back from break. For people in the classroom right now, I want to learn your name. So if you could write down your name on this piece of paper, please report it in 3 parts. So just help me to learn your name and put it on your computer or on your desk. Okay? If you need paper, here is the paper. Just review. Here.
Yeah.
Okay, great. Thank you. So for those students who joining us remotely, so we are introducing ourselves for those students who are in classroom, okay? I hope it is recorded. Okay, yeah. Okay, great. Thank you so much for put up your name tag. I try to learn all your names, okay? Hello and welcome. Can you put your name? And if you could, if you want to come on next class, we have to come here, okay? So bring your name tag with you, okay? Thank you. All right, so before the break, we did lesson 32, partial correlation. Now we'll do lesson 33, bivariate linear regression. So in bivariate linear regression, we want to explore the relationship between two variables. So maybe I will bring up the textbook. Where are you? All right, So in lesson 33, we are going to use a data involved in those variables: quads, okay, the quads, glutes, abdomens, arms, grip, injury. Okay. So let's open the data file for lesson 33, and then we go from there. So, file open, data, lesson 33. All right. So in this data, we have 1, 2, 3, 4, 5, 6 variables. And those 6 variables, injury is a dependent variable, something on the y-axis. Try to draw. So injury is a dependent variable. And other variables, those are different parts of the body, okay? Quads, glutes, abdomens, arms, grip. So what we are going to do, we want to combine the first 5 variables into one variable. Okay. Combine the first 5 variables into one variable. And to do that, we will calculate the z value for the first 5 variables. And then we add those z values together. And the result will be used as a predictor or okay, as x. Remember when you have x, y, okay? All right. So any questions before we do the calculation? Okay, go back to my data. So this is lesson 33. First, we are going to create z value. Okay. So go to Analyze, Descriptive Statistics, and then Descriptive. Move the first 5 variables. The first 5 variables. And then check out. Save standardized values as variables. Okay. I just want to, I'm just curious from your side, what will you look like? Oh, wow. You can use this computer. Gone. Okay. I thought you have to use the headset, but good. Okay, no problem. Yeah. Just wondering how it looks like on your end. Oh, thank you so much. Yeah. Okay, I get the idea. Okay, thank you. All right, so click OK button. So after that, we have the Z value here on original data. See, this Z value, oops. We have Z value for each 5 variables. Any questions? I'll stop for a moment. Okay, once we have those 5 Z value, we want to add those 5 Z value together, add 5 variable together, okay, to create a new variable. And the variable name will be Z total, maybe. So go to transform, compute variables. The variable name is ZTOT. And then TOT STR. This is the new variable name ZTOT STR. And this variable would be add all this together. You see the Z value, this Z value plus next Z value plus Z value plus Z value plus last Z value. So add all those 5 Z value to get one new variable. And then click OK button. All right, so we have a new variable, total. Z total, this one here. Okay, this Z total is the result of 5 Z value added together. So now we want to explore the relationship between Z total and injury. Okay, so relationship between Z total and injury. So to do that, go to Analyze, and then Regression. After that, select Linear. So injury is a dependent variable. Independent variable is the Z total we just created. That variable, that is an independent variable. And now quick statistics to see if we need. So make sure estimate is selected and model fit, also confidence interval. Confidence interval, check out. Usually we use 95%. Okay. Continue. Continue. and then click OK button. So now we get all the output. Okay. So if you look at the model summary, we have R squared. R is the linear correlation coefficient, R 0.325. So it looks like there is a moderate relationship between injury and body strength. Remember, when you add 5 variables together, those represent your body strength, all parts, okay? So, and R squared explained how much changes in Y can be explained by X. So in this case, 10% or 10.6% variation in injury are due to body strength. And you have standard error of the estimate. Standard error of the estimate. This number is actually the square root of mean square due to error. Here, mean square due to residue. 2,461.161. If you take square root of this number, 2,461, you will get 49.61. So make sure you understand the relationship because it might be on the midterm or final exam. Okay, so if I give you only 2,461, I only give you 2,461. I ask you standard error of the estimate. You just take square root of this 2,461. On the other hand, if I give you standard error of estimate is 49.61, I ask you mean square due to residue. You use 49.61 times 49.61, you will get 2,461. Okay, so might be in the midterm, might be in the final exam. All right, so the F-test statistics, you are going to compare F-test statistic with critical value of F to make conclusion. But since p-value is given, p-value smaller than 0.01, so p-value is universal regardless of which test. When p-value smaller than alpha, we conclude it is significant. Significant means this is a good model. Good model means there is a relationship between injury and body strength. Okay. So this is and also in this ANOVA table, when we review in week 1, week 2, in the previous week, you need to know the relationship between those, among those numbers. Okay, so I'm going to try to copy this to my OneNote so that I want to make a notation because this is important. Not copy and paste. I need to copy again. So if you look at the sum of squares, this number divided by degree of freedom, you get mean square. So 28,520 divided by 1 equal to 28,520. Next, mean squares due to residue. Okay, use 241,193 divided by degree of freedom 98. You get mean square 2,461. Okay. Again, this kind of calculation or relationship I taught in class, it might appear in midterm or final exam. Once you get this mid square, how do you get F value? If I delete F value, I only give you mean square due to regression, mean square due to residue. You need to know, using 28,520 divide 2,461, you will get 11.588. Okay, so 28,522 divide 2,461, you get F. This is how you get F. All right, so this model is significant. Next, let's write down an equation. We want to explore the relationship between injury and body strength. Okay, so the equation is based on two values. One is constant. When you're in high school, you have y equal to ax plus b. Okay, constant is your slope, or not slope, intercept. Next one, negative 4.891 is the slope. Okay, so when you're in high school, you write down, you write down y equal to ax plus b, something like that. Okay, so in this case, y is injury. Injury equal to ax, a is the slope, 0 negative 4.891. This is a slope times x. X is the overall body strength. Remember, x is you add all the 5 variables together. Those 5 variables represent body strength. Okay, so we call it maybe just strength. Okay, overall body strength plus slope, intercept 145.8. Keep in mind the slope is negative, means the stronger you are, the less injury you will get. It makes sense, right? Or the weaker you are, the more injury you will get. Body strength is strong, the less chance you will get injury because the slope is negative. Okay. And once you have this equation, you can make prediction. Okay, if one person's body strength, say, let's take a look at original data. So those are the body strengths. If I got one person, body strength is 3, can you predict the person injury? You just plug in the strength equal to 3, you get the injury. You can predict. Okay. All right. So that is a linear correlation. Explore the relationship between 2 variables. Okay, and the output we analyze here is important. The ANOVA table, the RR square, standard error of estimate, and these 2 numbers, slope and intercept, decide the equation. Okay. Any questions? All right, so that is lesson 34, lesson 33. Okay. And then last lesson for today, lesson 34, multiple linear regression. Multiple. The principle similar to simple linear regression, except you have many x. You have x1, x2, x3, and then only one y. x1, x2, x3, just one y. Okay, so that is multiple regression. Multiple regression. So let's do an example from textbook, lesson 34. Lesson 34. So this data I will close without saving it. Don't save. And this is lesson 32. Okay, I will open. Lesson 34, multiple regression, data file. Open. So it is similar context. It is study the body part strength and injury, but this one also consider the age and med index. It is a medical history. Okay. So I'll pull out the explanation of variable here. So lesson 34. So basically, multiple regression, we want to explore in this equation, we want to explore the relationship between x and between y and x1, x2, x3. Okay, there are multiple relationships. x1, x2, x3. Okay, we want to do that. So for our data, the explanation of the variable here, lesson 34. Those are the explanation of the variables. Okay. So those are the variable meaning, body strength plus age and medical history. So once we get this data, so we are going to conduct multiple regression with one set of predictors. So our research question would be, we have three. We'll do maybe those are the research questions. We answer the first question first. Those are research questions. So we want to see how accuracy can physically injury index be predicted from a linear combination of strength measures for people. So this is our research question. To answer that question, we go to the data set, lesson 34, and then we do analyze regression, and then linear. Dependent variable is injury. Independent variable, we have 5. Quartz, 2, grip. Those 5 variables, different body parts, okay, as our independent variables. And then quick statistics. Make sure estimate is selected, model fit, and usually we also need a confidence interval. For this one, we also need a part and partial correlation. And quick continue. And then quick OK button. So those are the output. I'm going to copy to OneNote, then we analyze. So this is a multiple correlation coefficient, 0.426. It is a moderate. Okay. People using 0.1, 0.3, 0.5. So anything below 0.1 is weak correlation. Okay, between 0.1, 0.3, moderate. And then 0.3 to 0.5. And then above 0.5 is stronger relationship. Okay. So those are the, so this one is moderate, linear correlation coefficient. R squared 0.182. Can somebody try to explain, interpret what is this 0.182? Anyone want to try? If you translate this to percentage, it means 18.2%. What does 18% mean? 18.2%. It means 18.2% variance in injury are due to the combination of body strengths. Remember, we have 5 independent variables. Okay. So 18.2% changes in Y can be explained by combined X, X1 to X5. Adjusted R squared usually adjusted for sample size and other factors. Standard error of my estimate, it is just the square root of mean square due to residue. We explained this. And ANOVA table is the format of ANOVA table exactly the same as we get from simple linear regression. Okay, so I will skip this one. And now, because we have 5 independent variables here, so when you have this number, when you write down the equation, you are going to based on standardized B. Okay, for those number here, based on this number, you can write down an equation. Okay, so the equation would be, remember what is my Y or dependent variable? It is injury. So injury equal to constant 260. Okay, 0.39 then quads plus 0.6, 0.628 times quads minus 3.245 times gluts minus 0.563 times admins minus 1.13 times arms plus 0.794 gripe. So that is the multiple regression equation. 1y with 5x. And you can, based on this equation, make predictions. Okay. And also you need to understand the significance here. SIG means p-value. Okay. Some p-value are significant, some are not. Let's check one by one. The quads, p-value for quads, 0.333, not significant. Not significant. If something is not significant, you can actually delete this variable from the equation, rerun the model so that it has only 4x. Why you want to delete quads? It is not significant. Okay. Next, gluts, the p-value 0.002. This p-value smaller than alpha. It is significant. You keep this variable. Next variable, abdomens, 0.406, not significant. You could delete this variable, but not at this time. When you delete variable, you have to do one at a time. So for example, the first time you run this multiple regression, you use 5x. When you delete one variable, which one? Quads. You have 4 variables. You rerun those 4 variables. And then the p-value will change. From those 5 variables, you delete one that is not significant. Then you have 3 variables. Is that clear? Until all variables left are significant. Yes?
Does it matter what order you take them out in? Like, do you do the highest one first?
It is matter the order. Which one would you delete? The biggest p-value, delete that one. Okay, you choose which p-value is the greatest. You delete that one first. Yes.
So just to make sure I'm understanding, the first one you'd remove and this one would be grip, right?
Let me check. I haven't checked. Thank you so much. It is Eric, right?
Yeah.
Yeah. So the first one, in this case, you should remove grip because p-value for grip 0.465. You should delete grip. Then you have 4 variables. Rerun it. Repeat yourself. Rerun it. Thank you all for your participation. That's great. Okay. Any other questions? All right. The other way is to look at whether it is significant or not. You can look at the confidence interval. If zero inside the confidence interval, that usually is an indicator not significant. For example, the last one, confidence interval for grip, negative 1.356 to positive 2.944, 0 between these two numbers. Do you agree? When 0 between lower bound, upper bound, that is not significant. That usually means p-value is very big. Okay. So any questions? So we actually answered one research question. how accuracy can physical injury be predicted from linear combination of the strength? The answer is how accurate. It is pretty accurate because the p-value for the model here, ANOVA table provides p-value for the model is significant. Okay. All right, so that concludes our multiple regression part. Because next week we have midterm, so we are going to have some time to just familiar yourself with the format of the midterm. Okay. So any questions for now? Okay, I'm going to stop recording, and then we all take a second break. After break, when we come back, I will help you to familiar yourself with the format of the midterm. You complete 3 questions. The midterm maybe have 30 questions. Just get used to what kind of question will be on midterm format. Okay. And I may also give you some scope, narrow down a little bit, because week 1 to week 5, that's a lot of content. Okay. All right, so break, let's say when we come back at 2:55, come back at 2:55 for those who are joining us remotely. Break time, come back at 2:55 for review for midterm next week. Okay, so back at 2:55. So I'm going to check the questions. Can you explain again about 95 confidence lower bound, upper bound? Okay, if the confidence interval includes 0, for example, from negative 1.356 to 2.9, 0 is inside this confidence interval. That means it is not significant. It is short here, p-value 0.465. It is not significant. Another example would be confidence interval between negative 5.306 to negative 1.1. Negative to negative 0 does not inside this range. So it is significant. You can get p-value 0.002 proof here. It is just another way to show significant or not significant. Okay, so this is one question from Liban. And another question, Moses, coefficient of determination equal R squared. Yes, correct, Mohans. Coefficient of determination equal to R squared. Okay. Okay, guys, take break, stretch, okay? Drink some water. Come back at what? 2:55, okay? I'm going to stop recording. When we come back, we stop recording, we can record again.